Hello friends, in this lecture we are going to discuss about the crashing of a project or a network. So this is the concluding part of the chapter. So in this lecture we are going to discuss about the crashing, some introduction topic, then time cost trade-off graph, then algorithm, the steps which are involved in network crashing, and finally the examples. So what is crashing? What do you mean by network crashing? Crashing is nothing but you try to shorten the path or the time of activities without sacrificing the cost involved in the project, right? You will assume that you are achieving the optimized project completion, right? So how do you achieve this? You will devote more resources, right? But cost is going to increase, but not that much. But you will try to complete the project even before the deadline. Clear? Also, so two focus areas are there specifically. First is you are trying to reduce the project duration. Let's say for example the project completes in 11 weeks, so you will try to do it within that deadline of 11 weeks, means 10 weeks or 9 weeks, but still you will try to minimize the cost. But you might be thinking that if you are reducing the time, you will definitely going to increase the cost. So let's look into that. Here if you see the graph, right, here it is the time and cost trade-off. So once the project duration, if you see here, as the time increases, the direct cost definitely decreases, but indirect costs increases. So total cost, total project cost is somewhat like this kind of curve. So what the company tries to find, this level here. If you see here, this level is the optimum level where you can crash the network or you can see the activities. Here it is the optimized one. Here if you go up on the top, you are trying to increase the cost, right? But this is the optimized crashing of the project, right? So what are the terminologies which are related to project crashing? NT is nothing but normal time. What is normal time means? It is the stipulated time duration in which the project can be completed. So NC is the crashing time. Let's say for example if the project is completed in 20 weeks and you are crashing to 1 or 2 weeks. So the crashing time is 18 weeks or 19 weeks. So you are reducing the project duration. Now again, the cost of activities NT, if the project is completed in 20 weeks, the cost is around say 5,000 rupees. But if you are trying to reduce the activity project duration, right, you are going to increase the cost factor on the project. So whatever project was costing around 5,000, now it is going to cost around 6 to 7,000. So what will be the cost slope? Cost slope is CC minus NC here. If you see here, CC minus NC upon NT minus CT. Here, this is nothing but the slope of cost. Here, so what is the algorithm? What are the steps involved in crashing the network? So first and foremost thing is you will find out the critical path. Based on the activities and the time durations of the different activities, you will find out critical path and critical activities which are taking the time to complete the project overall. Right? Maximum time to complete the project. Now, next step is you will find out the slope. So how do you find out the slope? We already looked into the formula here. Cost slope is CC minus NC upon NT minus CT. Here, for different activities, we will find out cost slope. Now, based on this cost slope, we will rank these activities in ascending order. Means the minimum cost slope, we will write down at the top. Why? Because we are going to crash those activities. What is crashing? We will try to reduce the project activity time duration. So here it is in the fourth step, it is written that you are going to crash those activities with the lowest cost, and then you are trying to find out the direct cost by adding cost of crashing to the normal cost. Now again, normal cost will already be there, but by reducing the duration, you are adding those costs to already this project duration. So we will try to add those costs. Clear? Again, you will modify the, or you will reevaluate the critical path, and the process is repeated, right? Why it is repeated? Because you are trying to reduce the project duration, but without sacrificing the those balance between cost and time. Right? It has to be balanced. If it is goes beyond the time factor and cost factor, it is no point crashing the network. Here we will see an example so that you can easily understand the network crashing. So here the example is given where a management of a company is interested in crashing the project by spending an additional amount not exceeding 2000 rupees. Means company has given the condition that the crashing, or you can reduce the project duration, but it should not levy the extra cost on company of around 2000 rupees. Clear? So we have to suggest how can we achieve this. What is the information given here? Activity is given here. Predecessor activity means the activity before this activity is given. The normal week time is given, means activity A takes 7 weeks, B takes 12 weeks. Crash time is given. What do you mean by crash time here? Means 7. If the activity A is taking 7 weeks, it can take, if we reduce the time, it can take 6 weeks. Means A activity can also be completed in 6 weeks, but the company is going to pay extra 3000 rupees. If they reduce the time from 7 to 6, normally it takes 15,000 rupees, this activity A. But if you are going to reduce the time, it is going to incur 18,000 rupees, means extra 3000 rupees. Clear to the company. In the same way, the information is given for other activities as well. Clear? Now let's start. So step 1, what will we do? We will try to find out the net critical path based on the network diagram. We will draw on the, based on this information given, we will try to draw the network diagram. A has no predecessor activity, so we will draw A activity here with 7 normal time. So 1, 2 is the event, and here the arrow is the activity. So A does not have any predecessor. Now B and C have A predecessor. So B and C has A predecessor, and B completion time 12 weeks and C 22 weeks. For D, the predecessor is B. Okay, so D starts when B completes. What about E here? E starts when C and D completes. So when C and D completes, E starts. Clear? E ends at 5 event number 5. So all the activity durations are also given. So let's find out the critical path. So whatever path which is taking maximum time. So let's start. 7 plus 12, 19. 19 plus 11, 30. 30 plus 6, 36. What about the bottom path? 7 plus 22, 29. 29 plus 6, 35. Which is the maximum one? 36. So this path in the red line is the critical path. 1, 2, 3, 4, 5. Clear? That is the critical path of 36 weeks. Means normal time of project duration completion is 36 weeks. Now this data was given already. Crash cost, up to crash cost is given. Now crash cost minus normal cost means 18,000 minus 15,000 is 3,000. 14,000 minus 11,000 3,000. 19,000 minus 18,500 is 500, and accordingly you find out the difference. Clear? Same way, normal time minus crash time. Normal time minus crash time. 7 minus 6 1, 12 minus 9 3, 22 minus 21 1, 11 minus 10 1, and accordingly. Clear? Now how do you find the slope? The slope is nothing but crash cost per unit time. Divide it. 3,000 divided by 1, 3,000. 3,000 divided by 3,000. 500 divided by 1, 500, and accordingly. Clear? Now what are the critical activities? Let's see. A, B, D, and E. Those are critical activities. Out of those critical activities, we will find the slope which has the minimum cost slope. Which has the minimum cost slope? E. So let's start with E only. So what is the first step? So what is minimum we can crash? for E activity, if you see here, E activity, you can crash up to 1 day. You can reduce the time up to 1 day. So let's start by 6, we reduce it to 5, right? So if you reduce it to 1 day, what are the cost slope? 500 per 1 day is the cost to the company. So 500 rupees extra cost will be there. And what will be the revised network diagram? Here, if you instead of 6, you will write 5. So instead of 36 weeks, now this network is going to complete, this project is going to complete in 35 weeks. Still A, B, D, E is the critical path. Why? Because the bottom one was how much? 22 plus 7, 29 plus 5, 34, and the top one is 35. So what is the critical path here? 35 weeks. So what will be the next step? Again, we will try to find out the slope, which is the minimum slope here. Again, after that, D, that is 1000, right? 1000 is the minimum slope after crashing E. E cannot be crashed further. So we'll try to crash the D activity from 11. So how much can we crash? We can crash up to 1 day only. So we'll crash 1 day with extra cost of 1000 rupees. Clear? Then we will try to find the network diagram. We will draw the network diagram again. Now what the network diagram says, 12, 19, 19, 29, 29 plus 5, 34, 34 weeks. Same way, 722 plus 7, 29 plus 4, 5, that is also 34 weeks. So there is a tie between these two. There are two paths, right? ABDE and ACE, which has completion time of 34 weeks. So we can take into consideration both of the paths. Clear? And the extra cost is 1000 rupees. So in step 5, if you see, we will try to reduce the project completion time, activity completion time of C from 22 to 21 because it has the lowest crash cost of 500 rupees. Okay, so 1 day we will crash. So cost is 500 rupees. So what is the critical path now? If you see here, 21 plus 7, 28, 28 plus 5, 33. Now here on the top, if you see 12 plus 7, 19, and 19 plus 10, 29, 29 plus 5, 34. So 33 is the critical revised network diagram with the ACE of 33 weeks. Now total project cost should not exceed 2000 rupees. So we will stop the crashing here. So what is the total project cost here? With the E crashing, we have 500 rupees. With D crashing, we have 1000 rupees. And again, with the crashing of C activity, we have 500 rupees. So altogether, we have maximum limit of 2000 rupees. So total project duration is coming out to be 33 weeks. So in this lecture, we have discussed about network crashing, introduction about network crashing. We also discussed about some terminology and time and cost trade-off. Then we looked into the algorithm and the steps of network crashing. And finally, we looked into the example of network crashing. So in next lecture, we are going to start with the new chapter, which is transportation and assignment. Till then, goodbye.